Section 9.5, the Gibbs-Duhem Equation. At constant temperature and pressure for any binary solution, we have this Gibbs-Duhem equation. N1 times d mu 1 plus N2 times d mu 2 is equal to 0. This is the Gibbs-Duhem equation as long as the temperature and pressure are constant. For any binary solution, you can use this equation. I will not prove this equation in the video. You can find the proof in any physical chemistry textbook. So first, how do we use this equation? We divide both sides by n, and then we have x1 times d mu 1 plus x2 times d mu 2 equals 0. Now we'll use this equation to prove this. If species 1 obeys Raoult's law, okay, and then we can prove species 2 must also obey Raoult's law. So first, if liquid 1 obeys Raoult's law, then we have mu1 in the solution is mu1 star plus RT ln x1. So over here, x1 is actually the partial pressure of 1 divided by the partial pressure, the pressure of pure 1. That's Raoult's law. And then we just plug in this expression here to here. And then we have this equation, right? And just to emphasize, this mu2 is the chemical potential of 2 in the solution. I put a solution here. All right, so this d mu2 and this d mu2 solution are the same thing. Now, d mu1 star is 0 because this mu1 star is a constant. Mu1 star is the chemical potential of pure 1. It's a constant. All right? So we just need to look at the second term. So we can take out R and T because they are constant. So we have RT times x1 times d ln x1 plus x2 times d mu 2 in the solution is 0. And then remember this dx is x times d ln x. Why is that? Well, the first derivative of ln x is 1 over x. So d ln x over dx is 1 over x. Therefore, x times d ln x is dx. Right? So you can do this on a piece of paper. You get this simplified. And then we copy this part here. Now, finally, x1 is 1 minus x2 in a binary solution. Okay, in any binary solution, x1 is 1 minus x2. Okay, so we got this negative sign here, and then we have this d mu 2 is RT times dx2 over x2. Now we integrate both sides. We have mu2 solution is simply mu2 star plus RT ln x2. So if you just integrate this, at first you might wonder if it's a indefinite integral, but you can have lower limit and upper limit. The upper limit is the actual x2. The lower limit is 1. So when you have a pure component 2, that's used as the lower limit or your baseline. And then you get this equation. So this equation tells you the chemical potential of chemical 2, component 2 in the solution is its chemical potential of pure 2 plus RT times ln x2. Again, this is a different form of the Raoult's law. I know Raoult's law tells you x2 is the partial pressure of component 2 divided by the vapor pressure of pure 2. Given that, you can prove this. So it's equivalent to Raoult's law. In the end, when we use this Gibbs-Duhem equation, we can prove that in any binary solution, if species 1 obeys Raoult's law, and then so does species 2. But, well, in the end, if both species obeys Raoult's law, it's gotta be an ideal solution. Well, another way to put it, so imagine we mix 1 and 2, right? We mix 1 and 2. If 1 obeys Raoult's law, that means attraction between 1 and 2 is the same as the attraction between 1 and 1. The interaction between 1 and 1 is the same as the interaction between 1 and 2. And that actually indicates the interaction between 2 and 2 is also the same as the interaction between 1 and 2. That's interesting.